All right, this is section 2.9, variation, last section of the chapter. So let's name some pairs of numbers where one of them is 5 times as large as the other. So for example, like 1 and 5, and 2 and 10. One of them is 5 times as large as the other. You could have 0.3 and 1.5. You could even make them negative. So how do you relate them all together in one equation that represents all the possible numbers? It'd be y equals 5 times x. The first number is x and the second number is y. We call this direct variation anytime it's y equals some number times x, and we say that y varies directly with x, or y is directly proportional to x. So for example, the number of dogs is directly proportional to the number of dog legs. You could have 1 dog and 4 legs, 2 dogs and 8 legs. These are assuming most normal dogs are going to have 4 times as many legs. So the legs could be equal to 4 times the number of dogs. Direct variation. Here, name some pairs of numbers whose product is 12. And can we come up with an equation? Yeah, so for example, 1 and 12, 2 times 6, 3 times 4. These are all pairs of numbers whose product is 12. You can even come up with some really strange numbers in decimals and negatives, but still the product is going to be 12, like 40 times 0.3. Or negative 12 and negative 1. In the end, the x value is still multiplied by the y value, and the product is a constant 12. It doesn't change throughout this example. There's 2 ways you could write it. You could write it y equals 12 divided by x. But either of those are... So you will see both of those equations used. In the end, it's still the same. 6 is equal to 12 divided by 2. This is called inverse variation. xy equals k, some constant number that doesn't change, or y equals a number divided by x. We verbally say that y varies inversely with x, and y is inversely proportional to x. So here, the faster you drive, and we're going to go the same distance. For example, let's say we're just going to fix 120 miles as the distance that you want to travel. And you've got some options. You could go at 30 miles an hour for 4 hours to get the 120 mile distance you need to travel. Or you could go a bit faster. You could go 60 miles an hour, twice as fast, increasing the rate, the speed, and then therefore decreasing the time by 1/2 down to 2 hours. You're still going to go 120 miles, a fixed distance. One goes up, the other one goes down. This is inverse variation. Next example, next kind of variation. If we name some circle radii and the resulting areas, let's say you had a radius of 1, and therefore an area, your area would be 1 pi square inches, for example. What if it was 2? Your radius were 2 inches, then the area would be pi times 2 squared, which is 4 pi square inches. If your radius were 3, then the area would be pi times 3 squared, which is 9 pi square inches. So you can see it's not direct variation, it's variation with the square. Y, the area in this case, is going to equal some constant times your input variable squared. The thing that doesn't change is the constant pi. You say that y varies directly as the square of x, or you could also hear people say y is directly proportional to the square of x. And I already showed you the circles. Now the goal is to produce an equation that fits the given information. So here, the spring problem. Our first immediate goal is going to come up with an equation. In the spring problem, Hooke's law states that the distance d that an elastic object such as a spring is stretched by placing a certain weight on it, varies directly as the weight w of an object. And so just knowing that, one of our knowns is going to be d is going to equal kw. That's the direct variation equation with the variables that we have. Now, in one case, if the distance is 40 centimeters, so for example, when this spring is stretched to 40 centimeters, the weight that's doing it is going to be 3 kilograms. And so using that information, what weight would be required to stretch the spring to 60 centimeters? What's unknown? Well, we could say we don't know the distance. No, we do know the distance is 60 centimeters. And what we don't know would be the weight. What is the weight when the distance is 60? We also don't know the value of k, the constant. And the k is going to be dependent on the spring. Every spring has a different k value. It's like the rating of a spring, how strong it is. So we need to figure out the k value for this particular spring. Let's figure it out. Our equation is d equals kw, and we know the distance and we know the weight. In one example, that's 40 centimeters times k is equal to times 3 centimeters. Solving for k, you get 40 over 3 equals k. That's the value of k for this particular spring. We're going to use that in another equation. Let's change out the weight, but we know now that the k value is equal to 40 over 3. Oh, I wrote that wrong. It should be w. 60 equals 40 over 3w. Solving for w, we might want to clear the fraction first, multiply both sides by 3 to get 180 equals 40w, and then divide both sides by 40 to get 9 over 2 kilograms. So the weight, you would need 9 over 2 kilograms, or just simply 4.5 kilograms, in order to stretch it 60 centimeters. Next example. Ohm's law states that the voltage V in an electric circuit varies directly as the number of amperes, some people call these just amps, I, of electric current in the circuit. If the voltage is 10 volts when the current is 3 amps, what is the voltage when the current is 15 amps? Well, right away, it's best to just write down the variables. Here's the equation. V is going to equal K times I. Now, what do these really mean? V is the voltage there, and the amps is I. As the voltage goes up, the amps, the current, is going to go up. And what is constant is the resistance. You can think of this really as water pressure, just water flowing through a pipe. The higher the pressure on one side, the higher the flow, because the pipe isn't changing. It's going to have the same amount of resistance. The more you press on the water, the higher the pressure, the more water is going to flow through. So what we know is V equals K times I. We also know that when the voltage is 10 volts, then the current is going to equal 3 amps. What we don't know is what is the value of K and what is the value of V when I is equal to 15 amps. So let's solve for K. 10 volts is equal to some resistance times 3 amps. So solving for K, we get 10 over 3. The value of K, the resistance for this resistor, is 10 over 3 ohms. V is equal to 10 over 3. And now we want to figure out what V is when I is 15. So the voltage is going to be, canceling out the 3's, voltage has to be 50 volts. This K is a measure of resistance, and it is independent of the amount of voltage. We measure resistance in ohms. All right, the amount of garbage, here's a garbage problem we got. The amount of garbage, G, produced in the United States varies directly as the number of people, N, who produce the garbage. So right away, one of the knowns is that G is going to be directly proportional to N, G equals Kn. We also know that there are 50 tons of garbage when there are 200 people. So when G is equal to 50 tons, N is equal to 200 people. What we don't know what G is going to be for the city of San Francisco. That population is given is 705,000 people. We also don't know what K is. So although we want to find G, our first step, an intermediate step, would be to find K. The equation is G equals Kn. Let's put it in for the case of San Francisco. For the isolated case of when you've only got 50 tons of people. 50 tons of garbage and 200 people. When you divide both sides by 200, you get K is equal to 0.25. Now let's scale that up to San Francisco. G is equal to 0.25 N, and so therefore in San Francisco, G is going to equal 0.25 times 705,000 people. This is a very old book. San Francisco has well over 1 million people by now. 176,250 tons. Next, find an equation of variation in which y varies inversely as x. And then they give you some numbers to plug in too. So inverse variation is x times y is equal to k. And so therefore you can plug in the numbers. 0.2 times 32 is going to equal some k value. When you multiply, you find the k value. That's 6.4. So therefore, xy is equal to 6.4. That is one answer. Another perfectly reasonable answer would be y equals 6.4 over x. It says find an equation, and so there are lots of right answers, and here's one of them. Here are two of them. Next, the time t required to drive a fixed distance varies inversely as the speed r. We're talking about a fixed distance going. The equation is going to be d equals rt, but d isn't going to change. Let's find out what d is. It takes 5 hours at 60 kilometers per hour to drive a fixed distance. So when you multiply those two together, you get 300 miles. Great. So the fixed distance is 300 miles. What if we go a little bit slower? What if we change it from 60 kilometers per hour down to 40 kilometers per hour? How long is it going to take? You divide both sides by 40, then you get t is equal to 7.5 hours. So the speed decreases and the time increases. That's inverse variation. Here's another kind of a variation. Oh no, this is directly as the square. This is find y varies directly as the square of x. So y is going to equal k x squared. And that's filling in the numbers to figure out what k is. That's 12 is equal to k times 2 squared. So 12 divided by 4 is 3, k is equal to 3. So an equation could be y equals 3x squared. Find an equation of variation in which y varies inversely as the square of x. So x squared times y is equal to k. Another way to look at this would be y is equal to k over x squared. Combining the two ideas we had before. Okay, so 6 squared, if x is 6, then plug in the numbers, times 1/4, that's got to equal k. And your goal is to figure out what that constant is. It's 9. So therefore the equation is x squared times y equals 9. You could also write y is equal to 9 over x squared. The answer here is an equation, and that's the goal for most of the section. So, begin 2i. That means copy the problem list into your composition books and then do the first problem. And I will see you in class.